Hello and welcome back. I hope you're feeling confident with polygons. We're going to move on to the next portion, which is parallelograms, and we'll get into classifying all the different properties of not only parallelograms, but also kites and trapezoids as well, and all the quadrilaterals, and in fact the entire family tree. And it's quite controversial. There's going to be some pretty fun things that we get to talk about this week as well. So I hope you guys enjoy that. When we come back next week, we don't have school on Monday because of Martin Luther King Day, so we have a nice 3-day weekend coming up, which will be really nice. I'll be able to rest and recover. And then we'll be reviewing all of next week. We've got a few assignments, 2 assignments for you guys to do for review, and then a practice test next week. And then the week coming after that, we will be taking the test in person. So that'll be when I grade all of the homework for this unit, and that's when all of the grades will be kind of going in for the second semester. So remember, you still have till January 22nd to turn in the homework from the first semester, and then the grades will be finalized, and I'll have to do paperwork in order to change grades after that. All right, so let's go ahead and get right into this. So we need to remember our angle pairs. This is something we did back in Unit 3, but it's going to be front and center with all of our proofs and our properties here. So we need to make sure to remember this stuff. So corresponding angles are angles that are in the same location whenever we have 2 parallel lines and a transversal that cuts them. So when the transversal cuts the 2 parallel lines, it forms 4 sets of angles, 4 sets of corresponding angles that are all congruent. So for instance, angle 1 corresponds with angle 5 because they're both in the top right, so they are congruent. Angle 2 corresponds with 6, 7 corresponds with 3, and 4 corresponds with 8. So all the 4 angles we have up here are the same as the 4 angles we have down here. And all the ones that are in the corresponding location are going to be congruent. Alternate interior are the ones that are on the alternate side of the transversal and the interior of the parallel line. So for instance, 2 is going to be alternate interior with 8, and 3 is alternate interior with 5. And then what's special about alternate interior angles is they're congruent. And I think we'll look into that and prove it on the next one. And then same side interior angles are the ones that are on the same side of the transversal and still the interior of the parallel line. So for instance, 2 and 5 are same side interior, so they would be supplementary. They even look like they're supplementary. They're clearly not the same. And then 3 and 8 would also be supplementary, same side interior as well. All right, so on this one, if we are given the angle up here as 100, we can move the corresponding angle down to here. So we would know that this angle here would have to be 100 as well, the one that's in the bottom right. And then once we know that, we can fill in all the remaining ones based on supplementary angles and vertical angles. So the vertical angle over here would also be 100, and that's actually going to be alternate interior. So the 100 here is alternate interior with this one, and sure enough, they are congruent. And then the same side interior would be the 3, which is going to be supplementary. So same side supplementary. So supplement of 100, which would be 80. Then the other angle missing here would be 80 as well, and you could fill in that would be 100. Those two would be 80 as well. All right, so now we're doing the same thing, but now it's vertical lines, parallel lines, so it might throw you off a little bit. This one's on the bottom left, same as the bottom left here, so those two would be corresponding angles. And then from that, you can see the vertical angle here is angle 3, and those two are alternate interior, right? So alternate interior angles, of course, are congruent, and then these two are going to be supplementary. So the supplement of 4 for angle 4 is going to be 110 because it's a supplement of 70, and then the vertical angle over here would also be 110. Okay, so that's what we need to remember from Unit 3. So the definition of a parallelogram is a quadrilateral where the opposite sides are parallel. So both sets of opposite sides, so these two are parallel and these two are parallel. All right, so then the next question I have are of all these other quadrilaterals that we have, other special kinds of quadrilaterals, which one of them are actually parallelograms? So if we look at a rectangle, rectangles, all the angles are right angles. Are they actually going to be parallelograms? So are the opposite sides parallel to each other? Yes, they are, so that one works just fine. What about a square? Is a square a parallelogram? Are the opposite sides of the square parallel? Yes, they are as well. What about a trapezoid? So a trapezoid is interesting because we have one set of parallel lines, but the other two are not necessarily parallel. Okay, so this one is not going to be a parallelogram. A rhombus, are both opposite sides parallel? Yes, that's true. What about a kite? Well, clearly those are not going to be parallel, so a kite has no parallel lines. All right, moving on. I guess we'll go back here. Yeah, so parallelograms include rectangles, squares, and rhombuses. And tomorrow we'll talk about the specific characteristics that we have for rectangle and rhombus. Baby daddy rectangle, baby mom rhombus. I know, just wait. And then, of course, their baby square. I know, it's going to be awesome. I did say it was a family tree, by the way. It's got some weird stuff going on. I'm just going to warn you for Thursday and Friday. There's going to be some Arkansas level stuff, if I can say that. I love people from Arkansas, and they probably say the same thing about us. So it's okay. Mutual respect. All right, so properties of parallelogram. So let x and y be supplements of each other. So x plus y is equal to 180, in other words. So whatever x is, y would be the supplement. So in that case, if we look at the opposite angles here, well, they both look like they're the same, and both of these look like they're the same. But how could we prove that? And if we look at our consecutive angles, how are they related to each other? Well, if we have parallel lines here, and this AD is our transversal, then that would mean that these two angles would be same side interior, right? Do you see that? So they're on the same side of the transversal, they're both on the right side, and they're on the interior of the parallel lines. Well, if they are same side interior, then that means they're supplementary. So, and we said the supplement of x is y, so this angle up here would have to be y. And then the same thing, these two lines, these two other opposite sides are also parallel, so that means that these angles here are still same side interior. So same side interior of this x is going to be the y over here as well. So what that means is that the opposite angles are going to be congruent. So just like vertical angles really, because they have the same supplement, right? And then the same thing here. These two are also going to be same side interior angles. So the supplement of y is right back to where we started with x. So again, both sets of opposite angles are going to be congruent, and the consecutive angles, the ones that are next to each other, are going to be same side interior angles, so they're going to be supplementary. So consecutive angles of parallelograms, the ones next to each other, are supplementary, and the opposite ones, like the blue and the green ones, are going to be congruent. All right, so let me show you that in action with the GeoGebra widget, which is pretty stinking cool. So I defined this where line AB was parallel to DC and line BC was parallel to AD. So that's how that's the parameters of this parallelogram. And if you notice, sure enough, the opposite angles are exactly congruent, and the corresponding angles add up to 180. Now, is that true for all possible parallelograms? Well, as I move this point in space, you can see all the other parallelograms that we have, and sure enough, the opposite angles are congruent and the consecutive ones are supplementary. So for all possible weird, funky parallelograms that I can make, which is kind of fun to play with, their opposite angles are always going to be congruent, and the consecutive angles are always going to be supplementary because they're same side interior. I just wanted you to see that real quick. All right, moving on. So properties of the parallelogram. So after that, we have to look at the opposite sides, and they're actually going to be congruent to each other. Now, the way we prove that is we need to draw or construct a diagonal that goes across from the two opposite angles. Now, once I create that diagonal, we still have parallel lines, right? So the blue parallel lines are going to cause 3 and 4 to be alternate interior angles. See how they're on the alternate side of the red diagonal and they're on the interior of the blue? So the blue angles are going to be congruent. Now the green lines that are parallel are going to force 2 and 1, the green angles, to be congruent as well, because they're also alternate interior with that red transversal there. So the blue angles are the same and the green angles are the same, because the blue lines and the green lines cause those to be the red transversal is going to be alternate interior. It's going to form alternate interior angles. Yeah, you get what I'm trying to say. All right, so from that, now that we have 2 of the angles are the same, we also know that the red diagonal is going to be reflexive and congruent to itself. So we end up with is angle side angle is the same as this angle, right? Those two are the same, this side and this angle here. So we have ASA, ASA. The only difference, as you can see, is that it's twisted, right? So it's flipped. But that's totally fine. So what that means is that the blue side is going to correspond with this blue side here, you know, the one next to the blue angle. And so the blue sides are going to be congruent to each other. So the side up here is going to be congruent to this side here, and this side is going to be congruent to this side as well, because the corresponding parts of congruent triangles are congruent. So we just proved the opposite sides of parallelograms are congruent. So not only are they parallel, they're also congruent, which probably already knew that, but we just proved it, only using the fact that we knew that the opposite sides are parallel. All right, the other thing is the diagonals are going to do something special to each other. So on this one, for the same reasons we had before, the red angles are going to be the same from the red diagonal, they're alternate interior, and the green angles are going to be the same from the green diagonal and the blue lines here. Okay, now that's, well, all we had to do is draw the second diagonal here, and these diagonals are going to do something special to each other. Now the next part we have is we already said that the opposite sides are going to be congruent, right? We proved that just a minute ago. So following from that, we have this angle, this side, and this angle is the same as this angle, this side, and this angle, which means that the triangles A and B are going to be congruent to each other by angle, side, angle, angle, side, angle. And once we know that triangles are congruent, all their corresponding parts are going to be congruent as well, which means this green side is going to be the same as the green side here. And again, those two are the same triangles, they're just flipped, just like we had before, which quite interesting. And the same thing with the red side is going to be the same as this corresponding red side over here. So what we just proved is that the diagonals are going to cut each other in half. Another word for that is bisecting each other. So the green diagonal cuts the red one into 2 equal halves, and the red one cuts the green one into 2 equal halves as well. Somewhere in there, I marked it. There we go. Okay, cool. So the diagonals bisect each other, and the opposite sides are congruent. That's what we have already proven. Now let me show you that with the GeoGebra widget again, just so you can see it move in space. So AE, which is this part here, and BE, which is that part, and then CE, and then DE, which is that part. So you can kind of see where these are matching up. Well, the 4.28 is the same as, or 4.26 is the same as 4.26 here, and the 2.38 is the same as that 2.38. And as I move these around in space, they're always going to match up. So the diagonals are always going to cut each other in half. Now they're not always, the diagonals are not always equal. That's going to be something else, but they do cut each other in half. So diagonals bisect each other. All right, now do both pairs of opposite sides have to be parallel or congruent? So in this example here, we have one set of parallel lines and these two sides are congruent. So if both were parallel and both were congruent, then we would be able to prove that it was a parallelogram. But right now it's actually ambiguous. It could be something else. So to show you that, we have this length here, and as I swing it in with the compass, you'll notice that we could have the exact same length over here that's going in instead of going out. That's still congruent in lengths, and the blue lines, of course, would still be parallel. So instead of having a parallelogram, if it swung to the outside, if it swung to the inside, they would no longer be parallel. They would in fact have to be an isosceles trapezoid, which we will talk about, I believe, on Friday? No, Thursday. Yeah, well, it depends if you're an A or B student anyway. It might be next week, next Monday and Tuesday if you're a B student. All right, so now let's review the properties of parallelograms. So a parallelogram is a quadrilateral where the opposite sides are first and foremost parallel. That's actually kind of the natural definition of a parallelogram, right? The opposite sides are parallel. So here I've shown the opposite sides are parallel. And then from that, if we added one of the diagonals, which of course is congruent to itself, whenever we have that transversal from the diagonal, we'd have two sets of parallel lines. So we'd have these lines here are going to be alternate interior, and then these lines here are also alternate interior, going off of the two parallel sides there and the one transversal. Once we have that, we have alternate, from the alternate interior angles, we have angle, side, angle, angle, side, angle. So these two triangles are congruent by angle, side, angle, meaning all their corresponding sides have to be congruent to each other, meaning the opposite sides of the parallelogram are parallel and also congruent. Then the diagonals, remember, those are going to bisect each other. So they're going to end up cutting each other in half. So this, the green one cuts the red one in half, and the red one cuts the green one in half by the proof we just did. The consecutive angles, which are going to be the ones that are right next to each other, those are going to be same side interior, right? So they are supplementary. So X and Y are going to be supplements. Those two are supplements as well. Then we have the opposite angles are going to be, because they're the same supplement of the same X or the same Y, they're going to be congruent. So the opposite angles are congruent because it's the same supplement of their same side interior ones, just like how we prove vertical angles are congruent. All right, 15 minutes, not too bad. Consecutive angles of parallelograms. So we're kind of filling in notes on the top here and then using those notes for that section, just so you can remember these properties as best we can. So the first one we're going to use is the consecutive angles, just like we have here on number 1, of a parallelogram are going to be supplementary. This means that they add up to 180 degrees, and this is since the consecutive, oh yeah, and then that's because they're same side interior angles, by the way. Then since the consecutive angles of a parallelogram are supplementary, we know the opposite angles of the parallelogram must be congruent. That would be like this angle over here would be the same as this angle over here because it's the same supplement of 51. This is because they're supplements of the same angle. Use the properties below properties to solve for the value of the variables in each parallelogram. All right, so 51 and x, those are consecutive angles. We know they're same side interior angles again because they're on the same side of the transversal and both on the interior of the parallel lines. And they're same side interior, they're same side supplementary. So what is the supplement of 51? So all we have to do is 180 minus 51, which is going to be 129. So this angle here, missing angle x is 129. On the side over there where you have 129 on the answer bank, go ahead and cross it out as you go. That way you'll make sure you'll know if you're doing it right. Then number 13, the next section. So since the consecutive angles of the parallelogram are supplementary because they're same side interior, we know the opposite angles of the parallelogram must be congruent. That's because they have the supplements of the same angle. We already talked about that, just kind of reviewing it again. This uses property to solve for the value of a in each of the parallelogram, or I suppose x and y. Just figure out all that information. So the opposite ones are going to be congruent. So y is going to be the same as 7x, but we can't solve for two variables at the same time. So instead, I'm going to use what I know about these two angles, which is that they're same side interior, which means they add up to 180. So I'm going to add them together. 7x plus 8x is 15x is going to be equal to 180. Then to solve for x, I divide both sides by 15, leaving me with x is equal to 12. So that's my first answer. Then I want to solve for 8x. Well, 8 times 12, just plug it in the calculator. That's going to be 8 times 12, which is 96. And then if this angle here, 8x is 96, what is 7x going to be? Or sorry, what is y going to be? That's what we really want to know. Well, the supplement, again, because those are also supplements of each other, the supplement of 96 is going to be 84. So we're missing angle for y would be 84. So those are three different answers you'll have on the answer bank there. The opposite sides of parallelograms are going to be congruent. So that one's pretty easy. They're parallel, they're also congruent. Use this property of the parallelograms to find the values of the missing variable x. All right, so on this one they have DG, which is this part here, and then EF is going to be this one here, and then DE and GF. All right, so we know the opposite sides are congruent, so I can set any one of these two equal to each other. So 2x plus 2 is going to be equal to 3x minus 3. And then I want to solve for x, so I'm going to subtract the smaller amount from both sides. So 2x, subtract 2x from both sides. If you do it to one side, you got to do it to the other. So we're left with 0, right? Plus 2 is equal to x minus 3. Then we move the minus 3 to the other side. We undo subtraction with addition. So add 3 to both sides. We end up with 5 is equal to x. So x is equal to 5. In other words, by the symmetric property. All right. Number 17 says we have a parallelogram where one side is 3 more than twice the length of the other side. So if it's 3 more than twice the length, that means it's going to be bigger, obviously. And so I'm going to say that the smaller sides are going to be x. And of course, so the smallest side we have is x. How would we write it as an expression where the longer side is 3 more than twice the length of x? Well, as an expression, that would be 2x plus 3, because it's 3 more than 2 times x, twice the length of x. And then since this is a parallelogram, we know the opposite sides are going to be exactly the same as well. So if this is x, the other side is x as well. Those are the same. And then they tell us overall the perimeter is 30 centimeters. So the perimeter is the distance all the way around. So I'm going to add all these together and set it equal to 30. So 2x and 2x, and then 2 more x is going to be 6x plus 6 is equal to 30. Then I subtract 6 from both sides. I get 6x is equal to 24. And then divide everything by 6, leaving me with x is equal to 4. And that's it. All right, the diagonals of a parallelogram form alternate interior angles with the opposite sides of the parallelogram. These alternate interior angles are going to be congruent to each other. Then the diagonal also forms pairs of vertical angles that are also congruent to each other. Use these properties to find the value of the variable of in each parallelogram. So the easiest one right off the bat is actually kind of working backwards. So looking at angle 2 here, if this is 82, 2 is going to be the supplement of that. So the supplement of 82 is going to be 98. So 2 is 98. And then we have, well, if we look at angle 1, the problem with 1 and 30 is that they're not actually alternate interior. They're not even same side interior because they're on two different lines there. So we actually can't use 30 at all to solve for this angle. But we can solve for 3 because on this one, 50 is alternate interior with 3. If you see your transversal here, I guess I could change colors. So you have our transversal, and those are parallel lines, so those are alternate interior. So 3 is going to be 50. And then if you look at the triangle, you actually have four different triangles here. We can figure out what the missing angle is by using the supplement, because we know all the angles of the triangle, interior angles, add up to 180. So adding these two together and subtracting it from 180 will leave us with 32 degrees. So angle 1 in this case would have to be 32 degrees, which was not the same as the 30 we had down there. All right, diagonals of a parallelogram bisect each other, which means they cut each other in half. So it's pretty straightforward. Use a property to solve for the variable of each parallelogram. All right, so the red diagonal is going to cut the green one in half, and the green one cuts the red one in half. Well, I don't know what the other side of this is going to be, so the only way I can solve it is by setting these two equal to each other. So I know that 2d plus 1 is equal to d plus 3. Then I want to subtract subtract d from both sides. Oh, that got off a little bit. But after I do that, I'm left with d plus 1 is equal to 3. And then we'll subtract 1 from both sides, leaving with d is equal to 2. So not too bad. Based on the markings, decide if we can prove whether each figure must be a parallelogram, then state the property. So we have 4 properties that we have, or I suppose 5 you could technically say, for parallelograms, right? So the opposite sides are parallel, the opposite sides are congruent, the diagonals bisect each other, the opposite angles are congruent, and then the consecutive angles are supplementary. So those are all 5 of our properties. So which one of those 5 properties is being shown in the diagram? And if one of them are being shown, we can actually use that property to prove that it has to be a parallelogram. Well, on this one, what they're showing with these arrows, or sometimes chevrons, is that the opposite sides are both parallel. So this side's parallel to that side, and that one's parallel to that side, which is one of our 5 properties for parallelograms. So yes, we can prove that this is a parallelogram because the opposite sides are parallel. And I'm just using symbols and abbreviating there because I'm lazy. All right, so list the property of the parallelogram that allows us to solve for x. So on this one, we are looking at the, ooh, that's actually not correct. So on this one, oh yeah, no, that is right. So we know the opposite sides are going to be congruent. So that's a property that we're going to use to be able to solve for x. And then you could set either one of them equal. You get it right, either one of the opposite pairs of sides. So I'm going to say that 2x minus 4 is equal to x plus 4. And then subtracting x from both sides, I'm left with x minus 4 is equal to 4. Then adding 4 to both sides, I get x is equal to 8. So that would be how I solve for x. You get the same thing if you set those two equal to each other as well. Those are the 5 properties of parallelograms. Tomorrow we'll be looking into different types of parallelograms that we have, specifically baby dada rectangle, baby mama rhombus, and baby square, and the different properties that they inherit from their different parents and stuff. And then where did those parents get those properties? I don't know. We're going to figure all that out this week. So stay tuned and let me know if you have any questions. I'll see you guys later.